Welcome to JVM Internals Interview Crashcasts, the podcast that helps you prepare for technical interviews. I'm your host, Sheila, and today we're diving into a common question for senior backend engineer positions. Joining us is Victor, an experienced Java developer. Victor, are you ready to tackle today's question?
Absolutely, Sheila. I'm excited to share my knowledge and hopefully help our listeners prepare for their interviews.
Great. Let's jump right in. Victor, here's your question. What is the JVM and how does it work?
That's a great question, Sheila. The JVM, or Java Virtual Machine, is an abstract computing machine that provides a runtime environment for executing Java bytecode. It's essentially a virtual machine that allows Java programs to run on any device or operating system without needing to be recompiled.
Excellent start, Victor. Can you elaborate on how the JVM achieves this platform independence?
Certainly. The key is in the compilation process. Java source code is first compiled into an intermediate form called bytecode. This bytecode is then interpreted or compiled by the JVM at runtime. The JVM acts as a layer between the bytecode and the underlying hardware and operating system, effectively abstracting away the differences between platforms.
That's a clear explanation. Now, let's dig a bit deeper. Can you describe the main components of the JVM architecture?
Of course, the JVM architecture consists of several key components. 1. Class loader, responsible for loading, linking, and initializing Java classes. 2. Runtime data areas, including the method area, heap, Java stacks, PC registers, and native method stacks. 3. Execution engine, interprets or compiles bytecode into machine code. 4. Native method interface, or JNI, enables interaction with native code written in other languages. 5. Native method libraries, a collection of native libraries required by the execution engine.
That's quite comprehensive, Victor. Let's focus on one of these components. How does the JVM manage memory?
The JVM's memory management is handled primarily by the garbage collector, which operates mainly on the heap. The heap is divided into different generations. 1. Young generation, where most new objects are allocated. It's further divided into Eden space and 2 survivor spaces. 2. Old generation, objects that survive multiple garbage collection cycles are moved here. 3. Permanent generation, or metaspace, in newer versions, stores metadata about classes and methods. The garbage collector uses different algorithms to efficiently clean up unused objects and manage memory allocation.
Interesting. You mentioned the execution engine earlier. Can you explain how just-in-time, or JT, compilation fits into this?
Certainly. The JIT compiler is a part of the execution engine. Initially, the JVM interprets bytecode, which is slower but allows for quick startup. As the program runs, the JIT compiler identifies hot code, frequently executed portions, and compiles them to native machine code. This compiled code is then cached and reused, significantly improving performance over time.
That's fascinating. Now let's consider a real-world challenge. How does the JVM handle memory leaks, and what can developers do to prevent them?
Great question. While the JVM's garbage collector is excellent at managing memory, it can't prevent all memory leaks. Memory leaks in Java typically occur when objects are still referenced but no longer needed by the application. Common causes include unclosed resources like database connections, improper use of static fields, and incorrect implementations of caching mechanisms. To prevent memory leaks, developers should 1. Always close resources properly, preferably using try with resources. 2. Be cautious with static fields and collections. 3. Use weak references for caching when appropriate. 4. Regularly profile the application to identify potential memory issues.
Thank you, Victor. That was an excellent and comprehensive answer. To wrap up our session, I'd like to offer some feedback and tips for our listeners preparing for similar interview questions. First, Victor did an excellent job of starting with a high-level explanation and then gradually diving into more complex topics. This approach demonstrates both broad understanding and in-depth knowledge. Second, he effectively connected different aspects of the JVM, showing how they work together. This systems thinking is crucial for senior positions. Lastly, Victor's ability to discuss edge cases and best practices shows practical experience, which is highly valued by interviewers. For those preparing, I recommend 1. Start with a clear, concise definition. 2. Be prepared to dive into specific components and their interactions. 3. Have examples ready to illustrate key points. 4. Consider performance implications and optimization techniques. 5. Be ready to discuss real-world scenarios and best practices. Remember, the goal is not just to recite facts, but to demonstrate a deep understanding of how the JVM works and its impact on Java application development. That's all for today's episode of JVM Internals Interview Crashcasts. Thank you, Victor, for your insights. And thank you, listeners, for tuning in. Until next time, happy coding and good luck with your interviews.